U.S. Army's Bradley replacement nears a major testing milestone. The U.S. Army's search for a replacement to one of its most iconic armored vehicles is entering a make-or-break phase, and a nationwide network of American factories is racing to prove its design deserves the job. American Rheinmetall announced that its Lynx XM-30 infantry fighting vehicle prototype is approaching delivery to the Army, a milestone the company says validates years of digital engineering work behind a vehicle designed to replace the M2 Bradley, the tracked troop carrier that has served as the backbone of American mechanized infantry since 1981. The XM-30 program exists because the Army decided the Bradley, despite decades of upgrades, had finally reached the limits of what incremental improvements could achieve against modern threats. Rather than adapting an existing vehicle, the Army structured the roughly $45 billion XM-30 program as a clean sheet competition between two industrial teams, each building a brand new infantry fighting vehicle from the ground up rather than modifying legacy hardware. American Rheinmetall leads one of those teams, called Team Lynx, bringing together companies including Textron Systems, Raytheon, L3Harris Technologies, Allison Transmission, and Anduril Industries, while General Dynamics Land Systems leads a competing effort built around its own Wolf XM-30 design, incorporating partners like GM Defense and AeroVironment. The Army awarded both companies roughly $1.6 billion combined in June 2023 to move from initial concepts into detailed design, prototype construction, and testing, setting up a direct competition where only one design will ultimately win a production contract. American Rheinmetall's social media announcement emphasized that the approaching prototype delivery reflects the strength of the company's digital engineering process, the practice of designing, testing, and refining a vehicle extensively through computer modeling and simulation before ever cutting metal for a physical prototype. August marks a major inflection point for the U.S. Army's XM-30 program. With prototype delivery approaching, our digital engineering foundation is proving exactly why modern programs must be built this way. Fast iteration, validated decisions, and configuration control that accelerates, not delays, capability. The result is a prototype designed with confidence, built with precision, and ready for the Army to put to the test, the company said. That approach matters because the Lynx XM-30 is not being built in one place, but assembled through a nationwide industrial network spanning multiple states, a structure American Rheinmetall has framed as directly supporting the Pentagon's push to strengthen domestic manufacturing capacity and reduce reliance on any single vulnerable supply chain. The company published a companion article detailing that distributed production network, arguing the approach both spreads manufacturing risk and creates skilled jobs across a broader swath of the American defense industrial base than a single centralized assembly line could support. The physical vehicle itself represents a significant departure from the Bradley it aims to replace. American Rheinmetall's design is based on the Lynx KF-41, an infantry fighting vehicle family the company has already sold to international customers, adapted for American requirements with an uncrewed, U.S.-designed turret mounting a 50mm cannon, a caliber substantially larger than the Bradley's 25mm gun. The vehicle carries a two-soldier crew inside the hull while making room for 6 additional infantry personnel in the troop compartment, and it incorporates a modular open systems architecture designed to accept new sensors, weapons, and electronic systems as they become available, without requiring a complete vehicle redesign. A design philosophy meant to keep the platform relevant for decades rather than becoming obsolete the moment newer technology emerges. Soldiers are expected to begin hands-on familiarization and evaluation activities with the physical prototypes in fall 2026, examining practical concerns including crew workload, visibility from inside the vehicle, how quickly infantry can dismount under pressure, and how easily maintenance crews can access and repair the vehicle's systems in the field. Those soldier evaluations feed into a broader Army testing timeline that includes placing competing XM-30 prototypes with the 1st Cavalry Division ahead of a rotation through the National Training Center scheduled for spring 2027, a demanding evaluation environment designed to simulate realistic combat conditions before the Army commits to a single production winner. Each XM30 platform carries an estimated cost of roughly $9.6 million per vehicle, according to Shepard Defense Insight, a price tag that has already drawn scrutiny given the Bradley's own troubled acquisition history and the sheer scale of investment the Army is committing to its eventual replacement. That cost pressure contributed to a moment of real uncertainty earlier this year when the Army declined to formally sign documentation finalizing a key program milestone in February 2026, a delay that raised questions across the defense industry about whether the entire XM30 effort might face further schedule slips or budget scrutiny before those concerns were at least partially resolved. The XM30 competition has become something of a proving ground for whether the Pentagon's newer emphasis on digital engineering, rapid iteration, and distributed domestic manufacturing can actually deliver a combat vehicle faster and more reliably than the slower, more traditional acquisition process that took the Bradley itself years to mature into the workhorse it eventually became.